Well, good morning, everybody. Here's what my plan is for this Friday. I want to talk to you about what happened a year ago. On May 10th, 2023, I started to recognize a pretty significant pattern shift, and I think it's a good lesson just to kind of rehash for this year, because at the end of this video, I want to cover some of the new long-range forecast information and go back to that year 2020 as a potential close analog. Not perfect, but close. I also, in the middle of this video, want to talk about the failure mode in the potential pattern break that we talked about that could last into the middle and end of May, and how we've recently seen some model shifts that have kind of pulled back away from that potential pattern shift. And also, I have to talk about yesterday's severe weather too. So here's those things kind of all laid out for you. Starting about a year ago right now, I began to lose a lot of sleep over the forecast. And one of the big reasons for that was the presence of this feature right here. We saw deep low pressure building in the North Atlantic Ocean, and it had kind of split the Bermuda High, pushed some of it, in fact, 3 different places, partly here, some of it there, and then one big piece of it back here. In other words, I say split, but what in reality was happening was with the depth of that low pressure system, the high pressure cells that formed around it were the results of displaced high pressure, if that kind of makes sense. And so the concern was, as this deep low built in the North Pacific, how long did it last? And if you remember at all last year in the weather forecasts, there were predictions throughout the month of May and in through June of the return of moisture. The models kept hinting at the return of moisture, but we could not break away from the presence of this large ridge sitting right in this area, and it affected the whole pattern across the entire country. So this is what it did. From April 1st, a year ago, to May the 10th, we saw jet stream flow that kind of came into the U.S. like this. It didn't keep diving. It kind of bounced again, but then met up over the east where the subtropical jet came through. And that is why April through early May last year looked something like this on the precipitation pattern. Essentially, there was a large area that was kind of left out of the flow, and things came together across the northern interior of the U.S., all the way from Washington, Oregon, clear through the Great Lakes into the Northeast. And then when the subtropical jet came in, that's where things picked up. So this was a year ago where we watched, after such incredible winter snow, so much of the Four Corner states in the Southwest getting into a broad section of the plains and western Corn Belt just get drier and drier and drier. Temperature-wise, we didn't break away to warmth. In fact, we had some late frost events last May, if you remember this, that got into, for example, I remember carefully the Corn Belt, the late frost events that came through. But this is what your average temperatures look like last April through May 10th. All right, what happened on May 10th was that low pressure center continued to work its way north towards Greenland. So the Bermuda High appeared to be moving over toward Europe. And do you remember this? There were the videos that emerged in, I think it was late May or early June, of a military parade in Great Britain where we had soldiers playing instruments were passing out from the excessive heat. And while that was all happening, this large area of high pressure built into Canada. And there was low pressure all around it to the south. And that high pressure cell did several things. And the first thing I want to make sure that you see about it was it did this to the flow. So this is anomalous mid-level flow in the atmosphere. It lasts May 10th through June 20th. And what we ended up getting out of this was anomalous flow that at times came out of the Northeast, through parts of Ontario, into the Great Lakes states, across the Corn Belt into the Western Plains, and just continued to flow in this direction. This is mid-level flow. And that particular setup in the flow pattern gave us this. One of the driest such time periods, May 9th in this case, to June 20th, on record in the Northeast, the Great Lakes, much of the Corn Belt, and where we had the wet conditions here was because this flow came around. And if you don't remember your kind of the geography and geology of the Midwestern United States, as you go this direction, you're going uphill. So you hear me talk about upslope flow a lot. That's a way to get air to rise. And so what happened was we had our best storms south where the subtropical jet were still sneaking through. When I say best storms, though, I'm talking about repeated severe weather events, massive hail across the south. I think Mississippi set a new state record last year. I have to go back and look that up. Maybe Texas did as well. But it was just nonstop rain here. Nonstop rain. And again, that was because the flow was coming around something like this. Why was it dry in Washington and Oregon? We almost had like the reverse rain shadow effect. Right? So normally, when the winds come from the west, the rain shadow is here. But if they come out of the east, the rain shadow is on the other side of the mountains, which hit the west coast pretty hard. And this was a really unique situation. And Personally, I did not do a very good job forecasting of when it was going to stop. It just didn't. And if you don't remember what also happened because of this, let's let this reload here. This is what we saw from space. So sorry that took a little moment here, but this was the wildfires in Canada, 18.5 million hectares of land burning. This is May 15th, May 16th. I mean, just take a look at the wildfires, which stretched from British Columbia at times. They then blew up later over in parts of Ontario and Quebec. And every storm system that came through looked dirty because of all the smoke that was getting absorbed into it. These kind of tendrils of smoke were not just here in May and June. They lasted into July as well, if you remember. And this was just an incredibly smoky year overall. Okay. That was last year, and last year was, in my opinion, one of the more unique years for a spring pattern transition heading into summer. This is right now. This is April 20th through May the 7th. And this year, I'm not focusing a lot on the Atlantic. Now, there are things going on in the Atlantic, like ridging that's happening in this area, but it's been a lot of discussion about that ridge, because this is what's driven stronger flow out of the Aleutian Islands, through the Gulf of Alaska, diving into the southwest, and then running up like this over what has been persistent, although at times weaker ridging that's been across the eastern part of the United States. This is the pattern that has developed, that has given us the incredible severe weather, this kind of rain shadow effect that's hit parts of central Kansas, but really hit other sections of the country that kind of are south and west of there that have been problematic. And this is what has just, really slowed down a lot of planting progress in the midsection of the country. Because if you look from April 20th to May the 9th, these are our precipitation ranks. So you now have places that a year ago were very, very dry. Just go back and look at this. That was a year ago. This is where things sit now. Is this what? Yeah. And sorry, I've got so many tabs open. And now we've got these northern climate reporting districts in Iowa that came off of 4 years of drought conditions that now just had their wettest stretch of days here. This is about 20 days in this look. And it's just been nonstop. And we've asked this question, is it going to stop? And I made a case that if the big high that is sitting right here, this is the one, if it moves east and gets toward the Pacific Northwest, then yes, the pattern's going to change. If it fails and goes back and persistence wins the day, then no, it doesn't slow down. And that's been our major story going forward. Now, what has that pattern done up to this point? Well, it's given us this map. This is the last 30 days, looking at total accumulated precipitation as a percent of normal. This is through May the 9th, which means this does not include the massive storms that ripped through this part of Texas last night or the heavy rains that moved into parts of the southeast. But overall, if you just look at the color bar, this is 100 to 300%, that little shade gradient right there. And again, I'll just make the same statement. We still have parts of Texas that are looking at 6 to 10 times their normal rainfall in a month. Okay, so here's where we get. All right, let's now start to piece this together. By the time we get into this evening, a couple of troughs to keep note of here. But all week long, we've been discussing this ridge that's building in to the northwest and the cutoff low that lives here. So let's get the evolution of this pattern. This is going through Sunday into Monday. That weak low sneaks out of the Four Corner states and delivers moisture into the drier parts of the southern plains. Meanwhile, cooler air tries to exit the northeast while warmth, much needed warmth, moves into the west. As we play into early next week, Monday, Tuesday, Wednesday, see the ridge living in this area? That was part of that transition, that shift that I was seeing that I thought could live a bit longer. But by middle of the week next week, as this ridge kind of sits in this area, there is a weaker trough. See it anchored right in through here that sneaks through. And it's going to follow this, which remember, today is the low that's sitting right over here. The point is to tell you that the midsection of the United States and east doesn't necessarily just break away drier. And what I don't like about this is now out there about May 17th, that ridge that was living in the northwest, well, I kind of see more of it here. And it almost looks like we're getting a bit of a high over low. That's a type of blocking pattern that's setting up once again in this area. And if you remember, if we see pressure changing back over to all high pressure in that area, we go right back into the pattern we've been in. So as we play this forward, this is now next weekend and getting beyond, and that's what happens. you see the heights begin to increase in this area. And that gives us flow that comes back in and does something like this. And this model trend was something we were worried about, that we thought the models were missing. And now we're starting to see that they're honing back into a return to another pattern that we've had, the one we've been seeing. And we just have questions because this is now not April 20th. This is May 20th. This is a month later. We're deeper into spring. We have longer daylight hours. The flow is technically a bit weaker than it was in April simply due to seasonal transition. And we want to know what that does to the precipitation pattern. So again, this ridge that builds into the northwest didn't have legs. It didn't last. We start to see higher heights building back into an area they've been. And we just are curious if this flow goes back into something like this. Now, what's missing in this pattern? In other words, you say, all right, does this really mean we're going to go back over really, really wet and just stay there and ruin planting through the remainder of May? Not necessarily. And one of the big reasons for that is there's no signal for a strong southeastern ridge. Now, if I've been talking about high pressure sitting here and these colors were really warm on this graphic, I'd say, oh, that's that classic check mark, no slowdown in the pattern. It's going to keep going. So it's not exactly the flavor where we just have persistent nonstop rain, i.e. 2019. Remember, we did that analysis last week. 19 big southeastern ridge. But overall, this pattern has gone away from a drier look and more toward a persistent look for where it's been. Okay, so where does that leave us? Well, early this morning, this is what we were dealing with. We had the severe thunderstorm watch box that was down here for all these counties where we're watching some active storms this morning. We've got, a lot of cold air, snow in the mountains here. We had the frost event that was moving through and a freeze event in northern Wisconsin here into this part of Minnesota. And what we're going to be watching, though, is finally getting away from this week's worth of chaotic weather. The front that is sneaking through here in the midsection of the country, though, is quite a bit cooler. Just notice all these blue and negative numbers representing the change from yesterday morning's temperature to this morning's temperature. And I was looking pretty closely as I was recording this about 5:20 this morning as to where the coldest air is kind of tucked away. And there's a few areas in through here that are getting this frost event this morning. But just take a look at yesterday's satellite data. I want to show you a couple of neat things on this. So automatically, you look across the north interior of the U.S., you can see the direction of the flow. That's where that cold air is coming from. But down here into parts of Texas, stretching all the way from Texas through parts of the southeast and down here into Florida, these were some massive storms that rolled through. And I also want to show you this. See how hazy the sky is in through here? Whenever we have a lot of just really, really humid air, and that's what's feeding into these storms, you get what we call particle activation or nucleation. So you have particles in the atmosphere. Some of them can be dust, debris, aerosols. It can also be smoke, or it could be salt. Any of that. They're all they all are water loving. They'll take on water. Water will condense upon them, and when it does that, it produces a haze. And that's what you can see here. Now, out west, we didn't have it. So it's a much clearer view of things in the west. The air was more pristine in this area than it is down here. But you can't make clouds and storms without impurities in the atmosphere. And some of the storms that blew up right here were absolutely enormous. I want to show you something. I'm going to zip out of this and go right over to some radar data. This is Dallas-Fort Worth, and we were watching some huge storms roll through just to the south of Dallas. And I want to come back to one more radar lesson here. First of all, you can see a very unique boundary. Do you see the boundary right there? Look at that frontal boundary sneaking through. But as you zoom in here, there was a report last night from this location. I apologize if you don't like the way I say it, but pecan plantation. That's the way I would just say it. I know in the South you can get in trouble for saying that word wrong. Pecan, forgive me if I'm not saying it the way you like it, but what I want you to see here is the pink. There was a storm that rolled over the top, and you can see the pinks that keep showing up inside of each one of these supercells, which are moving toward the south and east. And that is where the hail cores were in these storms. So thinking about that, let's go back and have a look at this, because the hail observed last night on radar was just enormous. I mean, take a look at some of these reports. We had a 4.5-inch hailstone reported out of that storm that rolled right in through here. And I just want to point that out again because the hail in this last week has been just enormous. So through early this morning, this is what our last 24 hours of total accumulated precipitation has looked like. And again, some of these storms have hit areas that have already had 6 to 10 times the normal rainfall so far this spring. The southeast finally getting some good moisture after what had been a drier stretch. And if we just kind of take this and go forward with it, early this morning, the Storm Prediction Center had upgraded to an enhanced risk across parts of Florida. We still see some areas here that have the risk of strong storms, but look, going into Saturday and then into Sunday, I'm thankful that I don't see large areas of severe convection out there in the forecast. So let's pick this up with the models and kind of see where things are going. As we play through the middle of the day today, we have unsettled weather, widespread showers that are through parts of the Northeast. We see the storms this morning, where we have the severe thunderstorm warning clearing out pretty quickly across parts of the Southeast. And then by this evening, there's a front that tries to sneak through right here. That's going to come through late this evening into the overnight hours. That's going to move through the upper Midwest. That clears by the time we get to Saturday morning, all the way over here to parts of the Ohio Valley. And this is where we're going to watch that upper level low that's over Arizona begin to move. And while it's doing that, it's going to be able to draw moisture pretty far back to the west, meaning we've got good precipitation chances coming in for some of those drier regions like on the Cap Rock and west of there. And you can see the models picking up on that by midday Saturday. Playing through the rest of Saturday, getting out here towards Sunday morning and then Sunday midday. It's going to be the movement of that low that's going to dictate the precipitation pattern kind of all across this area. So the low is sitting here, where it'll be on Saturday, through Sunday, Monday, Tuesday, watching this low come out is where the precipitation pattern is going to be. Okay, from there, let's take a look at the newest artificial intelligence forecast for the next 7 days. We do see that there is better opportunity to get drier air into this area. What I'm wanting to know is, does this area get some drier conditions? And we're looking quite wet across the south and wet into New England. Now, this right here is symptomatic of the return of troughs to the northwest. Remember, we know there's a ridge coming in, but this showing back up again on the models is what's got me concerned. It's not there yet in the NBM. See it? Major difference in the forecast. It's only there in the artificial intelligence forecast system. Everything else looks similar. What about the WPC? Again, not there, but everything else looks quite similar. Our wettest conditions right here along the Gulf Coast. What about the European model? It begins to show this, but the artificial intelligence is much wetter here, suggesting that troughs return to the Pacific Northwest, which is where ridging is now. Okay, so what about the GFS? It doesn't have it yet there either. And we just have to continue to compare models and understand that some of these differences in the models, while they may seem like subtle nuances, are going to be critical to watch. Because on this map, these colors represent where the GFS is wetter. This represents where the European is wetter. So pause and have a close look. What I want to do now is, though, give us an idea by looking at probabilities. So this is our chance of another inch of rain in the next 7 days. And a lot of this is going to be partly due to that low that comes out and how much moisture it's able to draw back into this area. But we have systems that are following it as well. So going out from day 7 all the way out to day 10, what I'm watching for is here. That would be telling me the return of troughs into the Pacific Northwest. On the really wet side of it, this is the chance. I just got the new model running. Man, my timing is always terrible with that. This is the chance of getting over 2 inches, which is highest here, and might as well show over 4 inches. Who's going to be drier? This is that area that's going to open up to some drier conditions. This is the probability of staying under ½ inch. This morning had a little trouble with the GFS run, so we're going to just look at the European, which I think has been the better performer anyway. So as we go forward, let's just take a look at this. Playing through Saturday into Sunday. This is now Monday of next week when that low begins to come out. So see the rain out ahead of it here. This is early Monday morning, playing through the rest of the day on Monday. There's a weak low that sneaks through here. At least it's going to leave a frontal boundary. And how far to the south that frontal boundary makes it will tell us the interaction between the low coming out of Arizona and where the rainfall is going to be in this area. But that's going to sneak through. And then what we're going to keep an eye on is by next Wednesday, that clears off to the east. And we still see some unsettled weather here in the midsection of the country. This is next Wednesday afternoon and evening. There's a weak frontal boundary that sneaks through. But right here, 1 week from now, is what I'm watching. Because if we can't maintain the ridge over the northwest, then we're going to send systems through this part of the U.S. You continue to see wet weather by next Friday and through here. And these were areas that previous model runs were drier simply because they built in a large ridge, the flow came over the top of it, and now that seems to be out of the forecast. This is why May is a tricky month, and that's why I told you at the beginning of it, we have to live week by week in these forecasts. So what does the new week 2 forecast look like? Well, let's start off with a 10-day look. This is what the European model suggests the precipitation anomalies will be over the next 10 days. If we just use day 7 through 14, this is what we get. New CPC, new European, and new GFS ensemble. Now, what did the European model do? It went wetter everywhere east of kind of where I'm painting in through here for week 2. And so what this could mean is more delays in this area for getting a crop planted. It's not going to be a temperature issue. It's just going to be too wet. We've already seen how much rainfall has hit in this area. So let's kind of build the narrative forward looking at temperatures. This last week, we've had really cold air that's occupied much of the west while warmth is built in here. As we look at the temperatures going forward, we'll wonder how many GDDs can we actually start to accumulate while the ridge lives in the west, because we're way behind on the accumulation of heat across the west. This is a GDD anomaly map since April 1st. So let's have a look now at what the frost risk is going to be. Again, a lot of this is this morning. You saw the cold air coming down the front range of the Rockies, still cold in parts of Maine. But the temperatures are expected to do this. Here's Friday's highs. Mainly where we've got cloud cover and the cold front that snuck through is where things are going to be cooler, much warmer across the west while the ridge lives there. There it is on Saturday and Sunday. There's all that warmth with the ridge that we thought could live longer. There's Monday, Tuesday, Wednesday of next week, and see some of the cooler air coming down. What I'll be watching for is any signal by next Friday for this to begin to cool off. So if we go from there and look out at the day 5 through 10, the models start to diverge beyond day 7 or 8. The GFS keeping the ridge around in warmer conditions here while letting cooler air invade into the midsection of the country, not cold, but cooler. And then you see that the GFS day 10 through 15 still wants to keep things warmer to the west. European is no longer having it. This is the day 5 through 10. Now watch. Day 10 through 15, it brings that trough back. So the models don't even agree out that far, which is kind of funny when I say, oh, let's just keep going and look farther out there. But we're going to do it anyway, even though I have no confidence in what I'm about to share with you. So all week long, I've been making this argument that if we take that ridge and move it closer to the Pacific Northwest and leave it, it changes our precipitation pattern in a big way. That was based on information I had back on the 6th when I was looking at this forecast saying, all right, let's build some high pressure into this area. Let's change this pattern across North America. And since then, from the 6th to the 9th, that has now faded. So the result has been a bit of a change in the precipitation pattern over the next 30 days. As you look at it, this goes out to mid-June. The models are picking up on drier signal here. Big question mark if we don't change the pattern. The wet in the south and up the east, sure. Could we get a little drier? Well, that'd be climatologically consistent with the northwest and the west and the intermountain west. But if troughs keep diving in here, I don't see how we break away to just consistent warmth. This would be fantastic if this actually happened because of how wet it's been right in this part of Texas. We need a slowdown here. But that is your new European model 1-month outlook. And I will be anxious to see later on today when the CPC releases their new forecast, what they've got for the week 3, week 4. So go to cpc.insep.noaa.gov and have a look at it. What I want to do finally here is take a look at some longer range stuff. Here's your latest ocean temperatures. And I've been making a case that we got to watch this. Now, what is that? That is the warm water that has gotten warmer over time as high pressures lived here. This is all one consistent story. And I want to know if it's going to go back there. And I also want to know if this warm water in the next 40 days moves toward the Pacific Northwest. Because if it does, it'll leave colder water here while La Nina gets going down here. And all of this is the setup for the pattern coming across North America. Now, what happened in 2020? I mentioned that at the beginning of the video. Well, this is what happened in 2020 by May the 8th. That warm water had already started to push. So that's a bit different. It left cold water here while weak La Nina conditions tried to move in. Atlantic stayed primarily warm, but we're going to develop hurricanes later in the season. From there going forward, from June 1st all the way to September 1st, this is what ended up happening. What was critical about that cold water living in this area was that it was very supportive of southwestern United States ridging. And that's where it got hot and dry. And the flow came over the top of it like this. And it cascaded through the country, bringing in places big storms, including on August the 10th, the massive derecho that went through here, breaking this drought that had been in western Iowa. That's what happened in 2020. Temperature-wise, all the heat was down there as well. And the reason why we were cooler here was because of the heat that was there and the flow that came over the top of it. So just take a look at 2020's summer. And again, it's not a perfect analog. This is this year, this is 2020, but there are some similarities here that I can't ignore. All right, what do we have this year? Well, I told you earlier in the week that the newest European model run went just a little bit more aggressively toward La Nina. It's still not technically forecasting a big La Nina pattern developing this summer or even by this fall, but it is much cooler than the older run by a little bit here. And a little bit's a big number when you think about the ocean temperatures. So it looks like this by June, July, August. So here's our question. Does this really come in and leave this cooler water there? Because if it does, while this La Nina tries to start to develop, it would make sense that it would want to plant the driest conditions here like it did in 2020. And in that case, you have flow that kind of cascades over the top of this, and you start to see the wetter conditions developing in this area. I mean, that's what I think is consistent with the meteorology of keeping cooler water here while warmer water noses in. That's why the June, July, August forecast looks like this from the ECMWF. Now, what about the others? Well, this is what the NMME is doing. It is also trying to nudge some of that warmer water here, but doesn't quite make it as far to the coast as the European does. It's got the cooler water there with a stronger signal on La Nina, very warm Atlantic. And as a result, this is what it's doing. Now, what was the major change? From last month's model runs, which were much drier in this area, it's now broken away to this risk of here having the heat and dryness, with the flow coming over the top, giving us those cascading storms, which once again goes back to that idea of hot and stormy summer here, hot and dry summer here with a weak monsoon. Now, it's just what the models are telling. I have to continue to watch the pattern evolve, but that's what I've got in terms of an update. So where do we finish? Let's go back to our near-term global outlook. A couple of things to take note of. Ukraine is relatively dry. A lot of this side of the Russian wheat belt is dry, but take a look just to the east of the Black Sea, wetter conditions in far southern Russia coming out of Turkey. This was an area that was extremely dry. South of the Yangtze, similar story, but the wetter weather is now farther south and to the west. Very wet throughout Indonesia, still some decent rains in parts of Queensland, New South Wales, Victoria, while we're drier in the interior. And the story in South America has not changed. I mean, you can see it right here. No change at all in the pattern we've been discussing. On the temperature side of it, we've got this. This would be the next 10 days. Much colder air continues to live in this part of Russia, but we're warmer throughout Europe. We're warmer throughout the Safrina areas, but we have the frost risk coming up from the south to Buenos Aires and Cordoba. And that seems to be the global things I think that are worth just mentioning at this point. So that is what I know. And I'm going to watch it all weekend, see if the pattern failure modes we've been discussing do occur. But I really appreciate hanging around with me so long today. But we had a lot to talk about. So you all have a good weekend, and we'll pick this back up on Monday. Thanks.